Can you confirm?
Yeah, the recording is started.
Great. So, hello everyone, and welcome on the first lecture for React.js. My name is Victoria. Probably some of you might know me already. I've read the lecture about accessibility before. So, yeah, a little bit about me. Um, I'm a software engineer here in EPAM for already more than 3 years. I'm mostly a front-end developer, work with React, Core.js and stuff. Read lectures and this one. Play with React and Vue.js on my custom projects, my pet projects, give Guir, Bswir, and Rolling lectures for Core.js, for React.js, and all other stuff. And mentor my colleagues at different mentoring programs here in EPAM as well. So yeah, nice to meet you all, guys. And I would like to start not from React today, but with something a bit earlier than React about the browser. I would like to talk about the browser and how it works, because it will give you a little bit of an insight of React work itself. So in general, why would you want to know how browser works? We work with JavaScript, with some frameworks, libraries, and stuff like that. So why to bother? Well, as a web developer, learning this information, the internals of browser operation, will help you to make better decisions in your workflow, in your solution, and stuff like that. And you will know the justifications behind development best practices that I will share with you. The other developers, colleagues, mentors, teachers will share with you and stuff like that. So you won't no longer be a person who just learns stuff. You will be the person who understands how it works, and in general, it will give you better performance, let's say. So what does the browser do? Main function of a browser, basic, to present your resource that you chose by requesting it from some server. So when you type the URL in the URL line, you kind of doing a request to a server, and the browser displaying it in its window, clearly as that. So we're going to go through the structure of the browser work, the flow, and reflow. So talking about the structure. So here you can see, we start from the user interface. It's your machine, mobile, just browser, laptop, I don't know, PC, sometimes even Kindle, stuff like that. So user interface, we start with that. It connects to the browser engine. Basically, it marshals actions between the UI and the rendering engine. It's kind of a mediator between two of these things. The rendering engine is responsible for displaying requested content. So as I told you before, when you type something in browser in URL line, you're kind of making a request. So this rendering engine is responsible for displaying stuff you requested. So for example, if the requested content is HTML, like we usually do, the rendering engine parses this HTML, plus if we have CSS, it also will parse this and displays the parsed content on the screen. And this rendering engine is connected to networking, JavaScript interpreter, and UI backend. Sometimes user interface can also do direct request to UI backend, but we will talk about this a bit later. So about networking. For network calls, for example, such as basic HTTP requests, when we need to get some data from the backend, we use different implementations for different platforms behind a platform-independent interface, or DNS for short. I'm sure some of you heard a bit about this already. Talking about UI backend, it's used for creating basic widgets. You barely would work with that only if you would decide to go to full stack or to backend development for JavaScript. So yeah, um, underneath of this, it uses operating system user interfaces methods. Something like I'm sure all of you heard about Amazon, for example, where we buy books, we buy stuff. Mostly Amazon known for its electronic books. Now it's a big platform that sells different kind of things, and they also have servers. So basically, you can buy computer that Amazon owns and put there your server. So you can see this UI backend and this computers that stay somewhere, I don't know, in Frankfurt or in LA, somewhere there. So you kind of do request there. You paid for it. It's kind of yours. You're using it. So stuff like that is mostly set behind UI backend. And so about JavaScript interpreter, it's stuff that's in your browser engine, not in browser engine, but in your browser. So for example, like V8 that we use in the browser, it's used to parse and execute JavaScript code, simple as that. So as you all know, I think you should know, we don't compilate JavaScript, we interpret it. So that's why we have JavaScript interpreter for Node.js. It's kind of different thing. Don't really remember how it's called. So for browser, it's V8. For Node.js, it's yeah. So yeah, for browser we have V8. For Node.js we have sorry, libview. That's why sometimes when we work with JavaScript and browser, we work with different kind of things that we work with than when we work with Node.js. Yep, so keep that in mind, but it's not for today's lecture. We'll have a Node.js course a bit later. Yep, so and from browser engine we go directly to data persistence. So keep understand this as just a simple data storage. We call it a persistent layer. So browser may need to save all sorts of data locally. For example, cookies, local storage, session storage. And browser also supports storage mechanisms as WebSQL, file system, and stuff like that. IndexedDB is also available for you in browser, though we don't use it very often. It's all of the searches are for very specific types of things. We mostly work with local and session storage and with cookies. Yep, so that's the structure of the browser. And I would like to talk a bit more about rendering engine. As I told you before, this thing is responsible for displaying your requested content. So how it goes, we request some file, like HTML file from the server. We requested it. It came to the browser and it starts parsing HTML to construct the DOM tree. Basically, DOM tree is HTML or a content tree. We can name it like that. So that's just a tree of your HTML. Boop. The next step is to render the render tree construction, and keep in mind that render tree and okay. Oh, I see. Sorry. For me, only one slide is shown. That's great. Give me 1 second, please. Hopefully I didn't go too far with my presentation. So how should I do that? Let me do like this. Okay. So yeah, back to the scheme. User interface goes to browser engine, goes to rendering engine, just like that. So again, user interface, it's your machine, laptop, or phone, computer, stuff like that. Browser engine is stuff that marshals stuff between UI, user interface, and rendering engine, sends stuff back and forth to each other, and rendering engine is stuff that displays what you requested, basically. So rendering engine starts with parsing HTML and creating content tree. Then it goes to creating a render tree. So if content tree is HTML tree, kind of relations between elements that put one in another. So parent element have some child component, stuff like that. Render tree is a CSS tree, so the same thing goes when we need to do some styling. It also need to create some sort of relations between elements. So that's what the second step of the rendering engine flow is. We create a CSS tree. Then rendering engine do a layout of the render tree. It means that it give each node of the tree the exact coordinates on the page. Like maybe you've worked already with this methods of the window of the element, when we can get the exact coordinates of this component on the page, on the display, and stuff like that. So on this step, this component, these elements get these coordinates, and they appear on the screen. And after that, painting the render tree happens. So basically, painting is applying all kinds of styles that we created on the second step. So in painting the render tree, we will be traversed, and each node will be painted using the UI backend layer. So painting the render tree also contains of two parts. It's reflow and flow and paint. Flow is layout of the render tree we sometimes call flow. Painting, yeah, that's just how it is. And these two steps can happen multiple times during the lifetime of your page. For example, so page appeared in front of you. You see all the stuff, the buttons, the text, and all kind of things. And for example, you scroll. Basic thing, we all scroll to see more data. It will reflow or re-layout stuff on your page, and yeah, that's basically it. The painting won't happen because we already applied some styles. So for example, if you open some model window, for example, you want to log into some I don't know, to the Facebook. layout and reflow or relayout and repaint will happen, because we need not only to draw a new element on the page, but to apply new styles to that. Sometimes painting can happen not only when we change styles, but other stuff. For example, if you just changing class of the element, painting will happen too, as well as reflow. Unfortunately, that's the kind of thing we have to face with. So these two steps are really important in further understanding of the React work and why we need React after all. Painting step is quite easy. It doesn't take browser too much, let's say, energy to do. Though layout step is really heavy, because you have to recalculate every single pixel of the page, basically. So when layout happens, you kind of get print of the page. And every time you do something on this page, if you change the position of some elements, this step will happen over and over again. So that's not good. That's why, for example, we don't use margin changing. We don't change a margin or position or stuff like that if we need to do some animations, because this changing both of these properties in the CSS will trigger reflow or relayout again. And that's not good. It will harm the performance. That's why we work with transform property. It triggers only painting, so it kind of doesn't move the element itself. It just changes color of the pixels to the place where you want them to be. That's how it kind of works with performance. Though, if we will talk about some more complex changes of the page, like adding new elements, or again adding showing model window, or stuff like that. Mostly, adding data, changing data, all kind of things. Layout will happen over and over again. If you want to show the element, if you want to hide element, if you want to I don't know, show the list of elements, like a giant list, and then allow user to change it, that would take a lot of performance from the browser and a lot of energy from it. So that's where React.js comes in handy. It helps optimize these processes of the browser and make our web pages more performable. So maybe you have questions at this point, because that was kind of not really straightforward things to explain. So if you have some questions, feel free to ask them, please. Is everything clear and I can move forward? Okay, great. Thank you. So React.js. This presentation that I created for you has about 120 slides. So that's why we're not gonna go through all of these slides today. This is for basically biggest part of our course. So during this course, we're gonna talk about React basics. We'll start with them, and then we'll go to more detailed description of the React. So talking about React basics, we start with main things. We'll go to stuff like JS6. What is that? How is it different from JS? Why do we need it in general, and what is that? We'll talk a bit about virtual DOM. How is different from just basic DOM that we've talked about already. We'll go to the component. So what component in React is, how we can determine them, how we can create them, what types of component there are and stuff like that. Slowly move to styling of these components that we already created. So again, there are a few methods that you can use to style your components, and we'll finish React basics with router. As we already talked about the URLs and stuff like that, again, React is used to create single page applications. Again, in scope of router, we talk about what is that. But yeah, it's kind of helps us to stay on the same page without moving back and forth with the browser. So yeah, that's another nice thing that React have, and would like, sorry, and that would be really nice to know. Talking about React details, we go through to the prop types. So the typing prop types help us to determine types of the data we pass between components. Lifecycle methods of the components. So there are kind of steps of the in the life of the component on the page. It starts with creation of the component and ends with its destruction. Let's say like that. I will talk about them in a bit. Hooks are a bit more complex thing. It would be hard to explain it right now, but we will talk about it. References, it's things that help us to get that data directly from the real DOM, let's say like that. Fragments, error boundaries, higher components and forms, more complex stuff. We'll talk about them a little bit later when we know what components are. So, what do we want? We want to stop predicting the future. When we create applications, most of the time we kind of predicting the future. We we think like, okay, user will go to this page, user will click this button, and then I should do yada yada. Or user will land on my page, they will fulfill some form, and I should do certain thing. That's how we kind of think creating basic application without something like React. We use pure JavaScript, pure HTML, we use simple data flow. We don't have problems with learning stuff because we don't have it. We don't have issues with using and stuff like that. So React most of the time give us same things. We still work with JavaScript. We work with something that looks like pure HTML, though it's not really pure HTML. We have simple and straightforward data flow with React. Learning React has really don't have really steep learning curve, so it's really nice to learn React, and there are a lot of information about it, a big community and nice documentation that you can use to learn, so that's kind of cool thing to do. With React, we also get reusable components. So for example, while implementing some pages, we create a lot of buttons or a lot of similar components. For example, if it is form, we kind of would have just a lot of inputs and they would change in type, and that's basically it. So in basic application development, we would just copy and paste them. In React, we could just create one element and reuse it. Yeah, as I already explained before, React have better performance in comparison to the application that wasn't implemented with React, just because of the flow, how React works with the page and how it avoids double, triple, multiple reflows of the page. And again, huge ecosystem of the React, help with learning, helps with finding solutions to the problem that you have and stuff like that. So that's also kind of nice. So it's important to understand that React is only a view library. So we don't have stuff to work with data in React. We don't have any backend stuff with React. We just only with Vue. We built React to solve only one problem, building a large application with data that change over time. So again, the example when we have some data on the page, for example, some table or list of elements, and it changes. User change it, or it changes from the data that comes from the backend server. For example, let's say we work with a shop, we sell phones, and users buy these phones, and at some point of the time, some phones will sell out. We want to change it right while some other person try to buy this phone, because in other way it will create some kind of confusion from a user point of view. So I kind of saw this phone, I wanted to buy it, it was available when I clicked it, and now you tell me that it's not. How so? That's weird. So in this example, we would use React to update the state of the component live while user is still on the page. So stuff like that. Or if we want to create some kind of table editing thing, some kind of application, web application, where we create some tables and we import stuff like Google tables, for example, React will come in handy again, because we would change that data lively. Components will reflow over and over again. So React will optimize this thing, help us to build more performable application. So React benefits. It has virtual DOM, so we're not working with a real DOM. We don't do reflows, repaints in real DOM. So it doesn't take that much performance from your web page. React have one direction data flow, so you kind of goes from parent to child, not vice versa. So that's kind of straightforward and pretty nicely understandable. Reusable components, we've talked about it already. It also have great developer tools. So for any browser, pretty much every browser you would like to use, it has something you could use for your to simplify your development. So for example, let's go to Google Chrome. For Google Chrome, it kind of have this extension, React Developer Tools. You can go there. I bet it isn't implemented with React. Nope, it's not. Okay, let's go to the Facebook. I would like to show you how React DevTools work and why are they so awesome. That's not what I wanted. Okay. No, I can't. Sorry. Unfortunately. Though yeah, with React DevTools, you kind of can see the tree of your components. For example, you can see how data goes from the parent to the child, stuff like that. You can control, not control, but it helps you to find some mistakes in your implementation. That's great. And also, it has kind of this extension, the profiler. It helps you to see how long does it take to certain component to appear on the page, so you can improve your performance. That's also kind of great, great thing to do, to use. Yeah, huge and growing ecosystem. A lot of there are dozen of developers that use React. A lot of companies, like quite big companies, already use React, and that's great, I think. Easy to learn, easy to use. That's true. It has great documentation. You can find everything there. If it's not enough for you, feel free to go to the blog of the Dan Abramov. He will help you, not help, but you can read a lot of interesting stuff there because documentation goes kind of picks the cherries of all the interesting thing you can know about React. And if you want to go deeper in understanding React, you can you can use the Dan Abramov blog. Dev community, again, straightforward. And yeah, I've talked about the big companies that already use React, and since this slide was created, much more companies started to use React, so that's kind of cool. So let's start with talking about React, and we'll go with how to start your first React application, or how to start practicing your React without spending dozens of time on setting up your environment and stuff like that. Especially when you start learning things, it might be a little confusing. So we can start with create React app. It is a CLI command provided by React. All thing you need to do is to run npm install -g create React app. It will install globally npm package with create React app, and then all you need to do is run create React app command with the name of the folder where you want to create your application, and boom, you would have your application right there. You can start it with npm start command. It will run, yeah, stuff like that. We can go with a little demonstration here. So let's go. Oops, that's not what I wanted. So let's install my create React application package globally into my machine. Everything is great. A few vulnerabilities, that's fine, nothing to worry about. And so I would like to create it on my desktop. Where is my desktop? No, I don't have my desktop. Perfect. Okay, let's just go with create React app. I'm using the new command that I have access to since I installed new npm package globally. My app is the name of the folder where my application will be created. Command not found. Perfect. Let me just turn off. Hello?
Yeah, here.
Yeah, great. Let's do it once again. Not found. Okay, maybe something wrong with Mac stuff. Doesn't matter. That would work, believe me. It's just the problems of the live presentations never works when you try to do that lively. So yeah, it would be easier that you would have a folder with index.js, with app.js, CSS and stuff like that. You can change it however you like and start doing things right there. You can also start with some sandboxes like Stackblaze or Code Sandbox. They provide already pre-created for you environments that you can use. As you can see, you can create anything, any project you would like. So for example, I would like to start with React, and boom, I have my application. It's already there. The same thing you would have if you would use Create React App on your local machine, though this thing would be even easier. You can just go and change stuff and it's already there. Good for practice, React itself, though at some point you would need to go to the real project on your local machine because it's just for you to practice JSX, relations between components, look at the packages on it if you'd like and stuff like that, because as you can see here, a few files are missing, like webpack config, for example, some Babel config, maybe if they don't use, again, Create React App and stuff like that. So that would be there if you set up your application by yourself. Again, if you use Create React App, you won't have stuff like webpack config or ESLint config or stuff like that, Babel config, but they will be there just in the inner files of Create React App. But yeah, that's how you can start head first with the React. So that's basically it was started with React. Let's go to the components and stuff like that. So thing you saw here in the app is not clear React. When we talk about React, we talk about working with library in the first place. So working with React means using its methods like create element or render. So as you can see here, we have two libraries added to our file of the component, React and React DOM. React is responsible for stuff like create element, working with components, passing props, stuff like that. React DOM, on the other hand, works with, as you can guess, with DOM. But you might ask me, why do we need it separately? Well, because we have React Native. React Native is a library for mobile applications. And if we work with React Native, we would still have React library, but we won't have React DOM as working with mobile. We don't have DOM. Simply as that. So that's why at some point of the time, these two libraries were separated and React Native came in place. To create element in React, we're calling the method of the React create element, simply as that. And the first argument would be the tag name that would be used to create this element. This is properties of this element that would be added to this element, and this is what would be inside of this element. So it's kind of child components, text nodes, and stuff like that would be as a third element, the third attribute of this function. So you might notice that class name kind of not really HTML attribute of the element, and that's true. for names of the properties and attributes of the elements, React use a little bit different names. So for example, here we don't use class, we use class name because class is a reserved name for creating a JS class, like thing that create objects. So that's why we can't use it here as a class. We use class name. So same thing for attribute for. We use it in labels to put an index of the input that is connected to this label. Again, for is a reserved word for cycles, so we can't use it as a property. That's why we use for HTML instead of that. So it kind of would be something like that, or HTML, I don't remember, something like that. So as you can see, we don't use for directly, we use for HTML to set up this attribute. Don't worry, you won't need to memorize all of this stuff. It's not really a lot of them. And while working with React, it would tell you if you would use just class, it would tell you that maybe you meant class name. It's quite smart in that case. So yeah, as a third parameter, you can pass another element that you created before. So for example, I would duplicate it, create element 1, and if I want one of them to be inside the other one, to make it div. No, let's make it this div. So if I want this element to be inside this one, I would just do that. And it will appear on the page, one inside another. Boop. So yeah, this is already something that I described to you. So that's the first argument, the type of the element. Second one is configuration. It can have all the properties that you pass to the element. Children, already talked about. It can be string, it can be an element, an array, if you want multiple of them, stuff like that. So in this code snippet, you noticed, sorry, you probably already noticed this line. And we're gonna talk about it now. So as I already told you, we have separately React and React DOM. So React is all about creating elements. React DOM is all about rendering this element in the real DOM. So your starting point, this kind of file you can see as your index file, the starting point of your application. It always would have this this line where you render your element, your core element. It would be your application. Everything that you would have in your app would be in this component, like a mother or the biggest parent of your applications. You can see it as a body in the HTML. Same here. This element that you would render in your in your page would be here. And the second attribute of this method is the place where you want to put this element, simply as that. And from this syntax, you can see that I don't have to have all my page written with React. If I want to, I can integrate just a small widget written on the React on the page that wasn't written with React. That was written with a plain HTML, CSS, and stuff like that. So the only thing I do is I put some element that was created with React, with JS, and would be rendered and handled inside this node by React. So yeah, this kind of thing that not everyone understands till some point that we can work with React on an application that wasn't written with React. Maybe it was written on with Angular, whatever you want. Maybe Vue or stuff like that with Java. However you like, you can do that. Maybe it's not the best decision, but you can do that. And again, the attributes of the render methods of the React DOM, the element to render, the first one, container, where would you like, sorry, where you would like to render this element. And the third one is optional. It's a callback function that would be triggered when the rendering of this element we pass as a first attribute finished. This create element function. So yeah, let me just, okay, yeah. So when we call the create element function, we get an element, but what this element is, you can see that as an object, and it is an object that has multiple properties like type, props, key, and reference. So type goes from the first argument of the create element. Props, basically everything that you put in the second argument of the create element function will go in the props property of the element and stuff like that. Key is a quite unique attribute of the element, and we'll talk about this a bit later. Hello world would go in children, also in props. As you can see here, we didn't put it in a configuration file, though it's still in props. So you can see that kind of this part, ID and class name went in props. Hello world also went in props as children. Might be confusing though. When we go further, you would understand why this works like that, and it's quite simple. Boom. So how to see this kind of code in the HTML, how to represent it in your head. So as you can see here, I create element 1 that is h1 with ID and class name that has inside it text node hello world. Here it is. I create a second element. It is already a div with ID, class name, and some text node again. Here it is. But till this point of the time, nothing appears in the HTML. Here I create another element, root, div, nothing in the props that have inside of it element 1 and element 2. That's it here. Again, till this point again, we won't see anything on the page while this executes, this JavaScript executes. When we come to this line, React DOM render, everything will appear on the page, only this point. So before that, we won't have everything that is inside of this div. So we're rendering root element that I created here with element 1 and 2 inside element with ID container. Here it is. And as you can see, everything inside it. That's simply as that. Pretty descriptive. I guess. Hope so. Yeah, and that's how it would look in the object representation. So we created a div with some children in the props. It has one object, the second object, and they both. I didn't write the first one because they're kind of similar. They both have type, key, and they also can have props, and they also can have its own children if you want. So you kind of would create this nesting one inside another. So at this point, all of that doesn't look really nice. It doesn't look logical. It doesn't look easier than just create HTML, and it is. It's not. Um, that's why we use JSX. JSX, it's something like JavaScript and HTML in combination. So it's still JavaScript, but with more features, let's say like that. So writing just with React, some complex component, though, as you can see here, it's not really complex. It's just div with few inner components, just a list, title, few text nodes and stuff like that. Not really complicated, and it would be easier to write in HTML. As you can see here on the left, that's how it would look writing it without JSX with plain React. JSX help us do stuff like that, much easier and more understandable in a way that will demonstrate you. So here on the left, it's not an HTML, it is JSX. So as you can see here, oops, the first line is just div with a text node and the closing tag div. The second one is more complex. So in a real HTML, we won't face anything like that. Custom tags, if we not work with web components, but it's another topic. Usually we won't face something like that, the custom tags. This is the sign that is JSX. So how it would look written with JS. So React create element to create div without any properties with the text node hello world. Then I create an element that I would call hello. Here it is, the tag hello. Null. We don't have any properties or customization, and with a text node hello world. So this line might be confusing because here we passed line, a string with letters div. Here we're passing an object, and that's correct. As I already showed you before, components are objects, so we can pass them as a first parameter of the create element if we need so. And at this point, we can use a feature of React of reusability of the components that we create with React. So as you can see here, there's a bit of the inside of the okay, never mind. Sorry, I got confused. So the one thing that you need to remember that React have a really certain structure. So for example, component is a one node, one element, as well as in the HTML. You kind of, if you have a list of elements, it's not a component. It's two separate components. So in order to create something like list, for example, I need a wrapper. So this thing would be considered as an element. So yeah, so this thing would be considered as an element. Cool. But if I, for example, need to create multiple nesting of this component, so I would need to put my div in a div, in a div, and then in another div. That doesn't look great. I want to just put my neighbors one in another and end with it. So JSX allow us to do that. It allows us to use React fragment. It's kind of same thing as we had with just JS in the browser. So for example, in a situation where we needed to create a list of the element, we would use document.create fragment, put all our elements of the list inside this fragment and put this fragment append use append child function and put this fragment in the HTML to avoid again multiple renders or multiple reflows of the page. Here works the same thing. We kind of have this shadow element fragment that won't appear in the HTML at all. It would just put everything that's inside of it in our HTML. So it will help us to avoid this deep hell. Yep. So as I already told you, J6 is the same as JavaScript, but a bit more. So as we work with objects, we can work with JS6 components as an expression. So we can pass it, we can add, we can pass it as an argument of the function, we can return it from the function, we can do everything we want. So here I created a simple function that if we have user passed in this function, we will return one component, hello friend. And if we don't have user passed in this function, we will return hello stranger, as we don't know this user. So that's how we can create kind of dependency on the data with React. So with a simple JavaScript, with the stuff that allows that browser allows us to do, that would be a nightmare to implement. And here we can just do this magic simply as that. So we also can use JavaScript statements, some of them in JSX. We cannot use, for example, if, we cannot use cycles and stuff like that, the simple constructions that can be transformed to expression. We cannot just create variable from if. We cannot create variable from for, though we can create it from the turner operator. So that's kind of same thing. Same thing. Though we would have this not true, but some variable, of course. This example doesn't make a lot of sense, though. Yeah. And as you can see here, you can understand this looking at the what JS6 is under the hood. It still React. It still transpiles to React.create element, though. Yeah, here we can see that everything that was put inside of our JSX came as a third argument of our create element function. So you cannot see this as an argument of some function. It won't work. That's why it won't work in JSX too. So keep that in mind when you create your elements with JSX. Whew, we are free to use string literals, the stuff that we got from JSX. Again, it would be transformed to the create element and transpiled by Babel if you use something like that. So here, instead of my, would be some kind of variable, and that's how you can create the variety in, for example, your classes or in the stuff you pass as a node, in the text node inside the element and stuff like that. Yep. So if you use some argument just like that, just as a name without applying some value to it, it will be written as true. So it would look like that. Sometimes it can be useful. It's just a small nice syntax sugar that you can use. So just keep it in mind. If you don't pass some value, it would be just true, and that's it. We can use in JSX, we can use everything from booleans to undefined, null, stuff like that, though they would be ignored. nothing would appear in this elements in the HTML. So we can use that if we don't want to render anything conditional. For example, if we check some data and some toggle was toggled off, we can use it to not render some component to pass null or just to pass false and stuff like that. So it is used like here to do stuff. So if show header is false, nothing would be rendered, just like that. And here you can see how React help us to manipulate not UI but the data. So we kind of just change show header value in order to manipulate UI. So we kind of don't work directly with UI as if we've been working as when we've been working with direct HTML or JavaScript, for example. You would need to call document.remove element, pass some, I don't know, class and stuff like that. Here, you don't need to worry about it. You just change show header and call it a day. Everything would work by itself. If this is false, nothing would show up, and that's great. Rendering a list of JSX expressions. That's an interesting thing, and every time I personally interview, for example, someone from lab, I would ask them how to render list of elements with JS. So without any framework, just like that. And that's a nice point to talk about stuff I've been talking here about reflow and repaint. So if a person knows what that stages exist, that one takes a lot of time, and if the person don't know, for example, about the fragments in the HTML, that's a red flag for me. So here, but while you're learning, while you're studying stuff with JS and things like that, you won't came across this very often. It's a really specific task that you might be assigned or not. That's why you might not know about this thing. And React allows you to simplify this thing, make it more performable, not that complicated, and really easy to do. So, for example, I got some data from my backend with a list of items. I want to display them. I want to display them in list. Simply, everything is simple. So here, for example, for example, imagine I got this from the backend or somewhere from there. I want to render it. I would call a method of the array map and transform every single element from here to component, and just passing some array. As you probably know, map just return a transformed array. So here basically we would have, instead of this expression after all JavaScript goes and runs and stuff like that, we would have a transform array, and just putting this array inside of the JSX element would just render this array, all of its elements one by one. So that's how we would render list of elements inside of this UL. Again, list, we created an element, we render this inside of the document with document element with ID container. Here it is. But console will give us the warning. Each child in an array or iterator should have a unique key property. And all you need to do is just to add this property here. For example, you can use a as we can see here, element is a string, so I would do like that. This key would be used in order to determine one element of the list from another. For example, as I told you, I requested the data from the backend. It was my initial load of the page. For example, user clicks some button and I load this data again. And I loaded the data like this. Something changed. Someone on the backend or in another side of the world changed data on the backend, and now it comes like this. From the human point of view, everything that changed is this element, this non-existing already element. But for the JavaScript, it's a completely different array with completely different data. So in order to make this action of the transform of the list more performable, we need to add a unique identifier. Here it's key. So React would use this key to check if this element was indeed changed to a different one or the same that already exists on the page. You might ask why I don't use index as if array, as it is array. Well, because of the same reason. Yeah, because of the same exact reason. Here, as you can see, I removed the second element. So this element already would have identifier 2, though it had identifier 3, but it didn't change. Nothing changed about it. So in this case, it would cause re-render of every element because React would think that it's different components, though they're not. That's why when we try to find something to use as a key, we try to avoid using index in the array. We use something else. Sometimes, most of the times, we work with data. So that would be some kind of an object with some ID inside it, or with some text and stuff like that. So in 90% of the time, you would find something better than just using index. So, yep. In the JSX, we also can add some events. So, for example, here, that's a nice small text. So here you can see that I created some element button with a non-click event. I added a simple function there, show price. Show price probably determined somewhere higher or lower, I don't know. But yeah, it would be the same as doing stuff like that. So everything you would want to use in a real DOM, in a real HTML, you can use in the JSX. So you might want to Google the name of the event you want to use and stuff like that. So this line would be transformed to something like this. Let's go back. Yeah. But the interesting thing about events in React and in JSX is that they are not real events. So they are synthetic events that were created specifically in React for purposes of this word to nivellate differences between of the different events in different browsers. For example, event that you fire in Safari might be a bit, like a tiny bit different than the event that you fire or handle in the Google Chrome or in Edge or Internet Explorer, for example. So that's why creators of the React created their own events that handle all of this stuff for you. That's another nice benefit of the React. So you don't need to remember how different events are or return different attributes in different browsers. You just work with the same one object of the event, and you happily ever after. Yeah, just a bit inside of the JSX and styles. You can add a style attribute as well as an HTML. You can do that directly on your component, and this styles would be in the form of an object. Again, pay attention that in the HTML we would use syntax from the CSS with a dash. You can see here. Here we would use a camel case like this. If you want to specify directly background color here, just specify the background. This would work too, but yeah, remember that it has different spelling just because of the thing that we work with JS. We cannot do like this in JS. That would be considered as a minus. Yep. So React support every attribute that you would find in HTML. So from the simple link, for example, SRC, to the something like access key, some accessibility attributes and stuff like that. But again, keep in mind that they have a little bit different spelling. Yep. So virtual DOM. I think. Yeah. Let's cover this topic today, and it will be the last one. And components we will start with in the next lecture. So, virtual DOM. When we talked about how the browser works, I already touched a bit content tree, HTML or DOM, real DOM, the kind of ladder of the elements of components, one nested in another and stuff like that. So everything we can see in the browser in here is a DOM, can be considered as a DOM. So every change of this real DOM, let's say like this, is a very expensive operation. That's why we don't want to do this a lot. That's why creators of the React came up with the concept of the virtual DOM. So how does it work? We change virtual DOM directly. We work with it with an object, as I showed you before. Every element inside of the other element, they are all object with the simple properties. And that's why it's easier and less expensive to work with virtual DOM than with real one. And additionally to that, we can combine a few operations. For example, wait for a couple of seconds to collect everything that happened during that time and do it at once. This would also help with performance, and that's what virtual DOM can also do. So, no, let's not talk about that. That's boring. So, in the reality, we actually have two virtual DOM. Wow, shocking. Why do we have two virtual DOM? The first virtual DOM is a copy of the DOM before it was changed. So this was before changes. This, on the second copy of the virtual DOM, we apply some changes. And what React algorithm. It's called reconciliation algorithm. What does it do? It compares to this both of these DOMs, find what directly was changed, and change only these two little nodes. So yeah, as you can try this later after the lecture with some sandbox. So here we can see that we created a function that creates an element with a div, some h1 text, h2, that inside of this h2 we execute new date to local time string function. Every time change, this would be called. We called React DOM, we render this element inside the HTML, everything is always. And we call this function tick every second with a set interval. So every time we call this tick, we create this element, we create all these lines, we render it inside the DOM. Though, as you can see on the screen, none of these lines has changed, only this one. So from this code, it looks like we're just replacing everything that was in a document container in this. Sorry, it should be right in this div with a new component. Though, as React used this kind of reconciliation algorithm and compare one virtual DOM to another, everything that it changes is this line, as only this was changed. So if we worked with a real JS, doing that would cost us a lot of performance, as we would change giant piece of HTML with another giant piece of HTML, and this every second. Imagine that. That would be horrible. So that's basically the magic of the React and how it does its stuff, how it helped the performance, just comparing two objects and not working with a real DOM directly. So let's ramp up for today. I believe you have plenty things to think about after this lecture. Maybe you have some questions. Did you understand everything I told you, or maybe something wasn't clear? We have a few minutes, like 10 minutes for a Q&A. Ask everything you want. Okay, everything was clear.
Seems yes.
Yeah, seems like that. Okay, thank you guys for joining today. And see you in one day. Have a wonderful evening and bye-bye.
Thank you. Bye bye.